Our next video of Chapter 5 is on medians and altitudes. A median is a segment whose endpoints are the vertex and the midpoint of the opposite side. So it goes to the vertex of the triangle and the midpoint of the opposite side is a median. And think median hits in the middle. An altitude is a perpendicular segment from the vertex of the triangle to a line containing the opposite side. So there are three different types of altitudes. The first one is an altitude that goes in as perpendicular to the bottom side or an opposite side of the triangle and lies inside the triangle. You can also have an altitude that lies outside the triangle. In the second example, where in order to hit the side perpendicular, the side would have to be extended. And the third type of altitude would occur in a right triangle where the two legs of the triangle are both altitudes. Now, based on these definitions, we have some more specific points of concurrency. So we've learned about the incenter and the circumcenter so far. And now we have the centroid, which is the point of concurrency of the medians lying inside the triangle. And the orthocenter is the point of concurrency of the altitudes. Now the orthocenter, similar to the circumcenter, can lie in different locations. So the orthocenter can be on the triangle, where the two altitudes, in a right triangle, where the two altitudes form the right angle, and the third one would also go through that. It could be outside the triangle, like an obtuse triangle. The orthocenter could lie on the outside of the triangle. Or it could be in the center of the triangle when it's an acute triangle. So, a couple concurrency theorems. First, we have the centroid theorem, which says the medians of the triangles are concurrent at a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. And I know this can be kind of confusing, so let's look at this mathematically. AG, the segment AG, is 2/3 of the full segment AE. BG is 2/3 of the full segment BF, and CG is 2/3 of the segment GD. Which also means that since AG is 2/3 of AE, the rest of that segment, GE, would be the leftover 1/3. And the same for all the other ones. GF is 1/3 and GD is 1/3 of the full segment. So let's actually look at this. AE, the full segment, is 6. BF is 3 and CD is 9. We picked some easy numbers that I'll divide by 3. So that means AG is 2/3 of AE. So AG is 4. BG is 2/3 of BF, so BG is 2. And CG is 2/3 of CD, so it is 6. Which also means that GE would be 2, the other 1/3 of 6. GF would be 1, the other 1/3 of 3. And GD would be 3, the other 1/3 of 9. So, if XA is 8, what is the length of XB? So we know XA is 2/3 of the full length. So XA is 2/3 of XB. So 8 is 2/3 of XB. And so we're going to multiply by the reciprocal 3/2, or divide by 2/3, however you'd like to think about it. XB is 12. Determine if AD, EG, and CF are medians, altitudes, or neither. Well, AD, it goes from the vertex to the midpoint. That would make it a median. EG is at the midpoint of one side of the triangle and somewhere on the other side of the triangle, which means it's not a median or an altitude. We can't even say it's a mid-segment because we don't know that G is the midpoint. And last one, CF, it goes from a vertex to the opposite side perpendicular. Well, that would make it an altitude. So AD is a median, EG is neither, and CF is the altitude. So a few things just to remember. The orthocenter is the intersections of the altitudes. The centroid is the intersection of the medians, or is the intersection of the medians. The incenter is the intersection of the angle bisectors. And the circumcenter is the intersection of the perpendicular bisectors. And those can be kind of confusing, so please make sure you know which one matches which segment. And that's it. We're all done with these types of points of concurrency. Bring your questions to class.